Students, we are going to discuss in detail on 3D bioprinting. So, in this lecture, we are going to see the concept of 3D bioprinting, 3D bioprinting process, and what are the printing ways, and how to select bioink, and how to start bioprinting, and what are the current advances in the 3D bioprinting. This is a device where we can see a liver is synthesized by a printer. The organ fiber, the reason for the development of 3D bioprinting or organ printing is only because of the organ failure that is drastically increasing nowadays. Often clinical treatments are really limited because of the poor availability of the donors. And if at all the donor is available, if it is the donor is not from the family side, means immune rejection of the donated tissue is happening in the case of the uh, organ. So, in search for this alternate for the repair or replacement of the malfunctioning human tissues and organs, the tissue 3D printing is being explored as a promising solution for this. 3D bioprinting this 3D bioprinting is nothing but as we have the organs, we have different layers in the organs. As we study in the case of the anatomy, same manner we prepare or print layer by layer by deposition of the cells to create three-dimensional structure that closely resemble to the normal organ which is found, and it carries out the basic biological function like a normal organ. For example, if you are preparing heart, means it should function like a normal heart, or if it is a liver, it should function like a normal liver. So, bioprinting process is successfully created to bioprint the tissues. What are all the needs for it, means we have to generate the bioprinting path in what are all the tissues which are required for bioprinting, and how what layer in layer by layer step we need, and that is a protocol for the printing process, and a selection of the appropriate bio ink which containing our uh, cells which are necessary for the particular organ. For example, if it is kidney, means we require nephron. If it is in the case of the liver cells, means we require hepatocytes. If it is in the case of the breast cells, we require adipocytes. And in the case of the heart, we require heart tissue, cardiomyocytes. Likewise, we have to choose the particular cells along with the necessary nutrient which is for the growth and development of the cells, and further once the organ is developed, it requires the network of blood supply also along with nerve supply for its functioning like a normal heart, normal organ, a heart or liver, whatever it is. And we have to have the control over the bioprinter and perform quality control after the printing is over. So, we are generating the printing path. So, we are how to create the printing path, means where we create a three-dimensional model of our particular organ. A medical imaging or CT MRI scan is taken for this purpose, or we create three CAD, that is computer aided design model is utilized for this purpose of creating the imaging for this particular artificial 3D model of our this one. So, we call it as organoid, the model which is synthesized. And further we develop slicing techniques. It's a process analogous to the histological sectioning. As we cut the tissue, we get layer just like um, a slice what we have. Same manner in the case of this, the printing path are created by slicing these STL model into layers and creating bioprinted tool paths that trace out the perimeter and interior feature of the each and every slice. We prepare layer by layer for the process of printing in this case. How to select the proper bio ink? The bioink is a bioprintable material which consisting of living cells and biomaterial that resembles that of the ECM to support the cells. Extracellular material to support our cells. The ideal bioink should possess proper mechanical and rheological and biological property of a normal cell. how to print, how to get a perfect shape in the case of the particular organ means in order to get a perfect shape of the organ, we require a scaffold on which only the bio ink is added, in which the cells are aggregating together. So the scaffold is consisting of cells dispersed in a biomaterial that helps to create a conducive environment for the cells to proliferate as well as providing a structural support. So what are all the scaffold free bioinks are also available. The cells are bioprinted without supporting any hydrogel and therefore they are loaded in higher concentration which then deposit on their own in the extracellular material. The types of bioinks used include natural and synthetic. The natural includes collagen, fibrin, chitosan and alginate, whereas synthetic includes methyl acrylated gelatin, fluoronic acid and polyethylene glycol and a combination of both. The decellularized matrix consisting of components obtained by chopping the tissues into smaller fragments. We lyse the tissue and we extract them and we remain them in the extracellular medium. Scaffold based bioinks. Scaffold based bioinks, we will have a mold of the scaffold to which only to the pore regions where we add our cells. The microcarriers have been utilized for bioprinting to increase the cell density in the bioink. They are porous particles designed to promote the cell attachment and survival and expansion. These are all, we can see the microcarriers in which the cells are lodged. The cells are present in the free suspension. And when this bioink is loaded in the hydrogel, the syringe barrel injected and it is extruded as a filament to form the particular structure. Here we can see that how the bioprinter works. Some of the printer organs are shown over here. Cell source. The cell component of the bioink should be autologous of the patient. So there are three types of cell sources are available. Autologous, autogenic, allogenic and xenogenic. Autogenic means from their own tissue the cells are extracted and it is multiplied and then they are utilized as the bioink for the process of this. That is autologous or autogenic. And allogenic means it is transferred from the kith and kin. What do you call it as allogenic? Whereas xenogenic is from the different species. Kith and kin, either it is donated, the autogenic means it is donated by the kith and kin or from their own tissue it is taken for this purpose. And allogenic, it is from the donors where we derive and we use it for the production of the bioink. And xenogenic means from the animal species. For example, we can derive the cells from the pig, etc. Pig, goat, something like that, which is relevant to us. And stem cells are utilized for the purpose of development. If we don't get a proper, the reason is that the stem cells are capable of converting into any shape of the particular cell. So there are pluripotent and totipotent stem cells are available. Pluripotent stem cells can differentiate into other cells. For example, hematopoietic stem cells can able to differentiate into RBC as well as WBC, different form of the cell. Same manner, similar such cells are available. In the case of the embryonic stem cells, we isolate the cell from the fetus and we develop into various form of it. So the 3D stem cells are having potential, property of self-renewal and potency. It is representing the unlimited source for the 3D bioprinting and it is a regenerative medicine. However, the autologous adult stem cells have been obtained invasively through the bone marrow and we harvest it. And adipose tissues are extracted by liposuction by this process. Stem cells are used in the 3D bioprinting. The human-induced pluripotent stem cells are utilized in the year 2006. We call it as iPSCs. The patient-specific stem cell lines are now created from mature cell types such as peripheral blood mononuclear by venipuncture and skin by fibroblast by skin biopsy and we have the ability to reprogram the patient specific cells and allowed to create stem cells and contain heritable mutations. The problem in reprogramming of our cells, there is where mutation is the major issue when we reprogram it. So then it should not create such problems. So we must be very cautious in reprogramming of the particular cell, which can be bioprinted and studied. So there is an potential to improve current understanding of the disease mechanism, thereby minimizing the rejection when we transplant back to the host in the case of the tissue regeneration. Here we can see that how the bone marrow stem cells are derived and fibroblast, and it is a viral reprogrammed and blastocyst. All these are generated by this technology. That's all. How to start and bioprinting. This three different types of bioprintings are available: extrusion based bioprinting, inkjet based bioprinting, and laser assisted bioprinting. Extrusion based means just by injecting it, just like as if you are preparing semia at home, no, same manner like this the extrusion will come out. And ink based just inkjet based bioprinting, it will be like our gel pens, where it comes out. The piezoelectric actuator or heater is responsible for the pouring of the bio ink into droplets. In laser assisted bioprinting, a laser pulse is applied and it will, a donor slide will be present, the energy absorbing layer will be there, then it is coming out in the form of droplets, and step by step the layers are printed in the laser assisted bioprinting. So inkjet 3D bioprinting, thermal and piezoelectric. Thermal means by heating process where we can do it. Electronically it is heated and is controlled also. The printer head is controlled, and during the printing process, the printer heads are squeezed by a thermal or piezoelectric actuator. Thereby it is producing the droplets on the controlled size. Inkjet 3D bioprinting is a low cost, similar to the commercial printers what we have in our day-to-day life. It's having high printing speed, relatively high cell viability. Nearly 80 to 90% of the cells are viable in nature. Extrusion based bioprinting, micro extrusion bioprinters, pneumatic, piston and screw types are available. Extrusion means, as I told, it's just like creating semia at home, no, where we press it. When we press, automatically it comes like noodles, no, same manner in the case of this. The extrusion of the ink is coming out. Along with that, the extrusion uses either air force pump, pneumatic means automatically it comes out, or we make use of the piston for pumping it by air force, or by screw and valve. A mechanical screw and plunger is dispensing the bio during this process. And laser assisted energy absorption layer will be there. Laser pulse will be assisting in creating the droplets, and donor side will be present. The focused layer pulse is applied to stimulate the small area of the absorbing layer. This layer pulse vaporizes the portion of the donor layer and creates an high pressure bubble at the interface of the bio ink and propels the bio ink. What are the current advances in the case of the 3D bioprinting? Where we are creating cardiovascular tissues, we can proliferate cell types that exhibit synchronous macroscopic beating and self-assembles along with our endothelial cells. And we can fabricate 3D muscles. These bioprinted cells are highest viability responding to electric pulses. Neuronal tissues have been bioprinted with high cell viability and basic cellular phenotypes, and functions over 2 weeks of post printing with successful development of sodium potassium channels like a normal neuron. Hepatic tissues are also prepared, which is similar to that of the native hepatocytes, demonstrated by the albumin secretion and capability of morphological analysis. Once the bioprinter constructs been shows morphological organization, the native liver environment and higher level of the liver specific gene expression, metabolic product secretion and cytochrome P450 induction, all those things. Recent advances involves the printing of our skin full skin equivalents using alternative layer of bioink and dermal fibroblast as suspension that shows high viability after printing. These bioprinted skin are further applied over the wound site and they are responsible for the enhanced wound closure as well as reepithelialization that controls the treated one, the fibril collagen hydrogel. So, thus 3D bioprinting using stem cells has shown much research progress in multiple organ system. Common challenges faced in the multiple organ system includes vascularization, that is providing connectivity of blood vessel as well as nerve tissue, and more further we have to check for the viability of the cells, how long it is viable. So if it is our own organ means it is as we age the organs to age, but whether it will stop its function or not we don't know, but we have normal organ can function, but in the case of the this one the problem is there, viability and scalability. Tissue engineering uses 3D bioprinting technology as promising clinical potential for various organs. We'll see the tissue engineering, how the biofolds, scaffolds and tissues are synthesized by from the various sources later. Thank you.